Good morning, dear friends. Today we are going to discuss about mixture requirement for idling, cruising, and high power. The mixture requirements for idling, cruising, and high power ranges of the engine are as shown in figure. You can see idling range, cruising range, and power range in the figure in the graph. First, idling range. The engine is said to be idle when it is operating at no external load with the throttle almost closed. At idling, engine requires a rich mixture as shown in figure by point A. It is because of following reasons: the mass of exhaust gas remaining as a residual in the clearance space at the end of exhaust stroke remains fairly constant throughout the throttle range. On the other hand, the mass of the fresh charge induced on each intake stroke depends upon the manifold pressure, and therefore it depends upon the throttle position. The manifold pressure and hence the mass of fresh charge induced during idling are almost, or we can say much less than those during the full throttle operation due to the restrictions imposed by the throttle. The result is a much larger proportion of exhaust gas being mixed with the fresh charge under idling condition, causing dilution of the fresh charge. The presence of exhaust gas reduces the intimate contact of fuel and air particles, resulting in poor combustion and thus causing power loss. It is therefore necessary to provide more fuel particles for enriching the charge. This increases probability of contact of fuel and air particles and thus improves the combustion. As the throttle is gradually opened, you can see in the figure from point A to point B, the exhaust gas dilution of the fresh charge diminishes. Mixture requirement then proceed along the curve AB to a linear fuel air mixture ratio. Second is cruising range. You can see in the figure range shown by point B and point C. The engine is operating at part throttle condition. The main objective is to obtain the maximum fuel economy. Consequently, in this range, it is desirable that the carburetor should provide the engine with best economy mixture, which is slightly leaner than the stoichiometric air fuel ratio, or we can say stoichiometric mixture. With lean mixture, the flame speed is relatively slow and even slower when the mixture is diluted with exhaust gases. Hence, the spark is advanced as the manifold vacuum increases. Third is high power range. During high power operation, when the engine operating with a fully opened throttle, the engine requires richer mixture. You can see in the figure the graph shown by point C to D. It is already has been observed that the mixture requirement for maximum power is with a slightly richer mixture than the stoichiometric. The carburetor has to set in the vicinity of the best power mixture. At high power, wide open throttle increases the mass of flow of the charge to the cylinder, which increases the demand of the rate of heat transfer from critical areas such as exhaust valve. This demand could be reduced by enriching the mixture, which is turn reduces flame temperature and cylinder temperature, thus also reducing the cooling problems and the possibility of damaging the exhaust valve. Therefore, the charge should be enriched before the throttle is made wide open. The rich mixture lowers the temperature in the combustion chamber and helps in reducing the possibility of detonation and the formation of oxides of nitrogen in the exhaust.